How's everyone doing here? Can you hear me all right? We're all good? Great. I've never had a stage before where I could sit down during the presentation, so we'll see if I make use of that at some point today. Well, today I'm going to talk to you about scaling Avalanche with subnets. It may sound like a broken record at this point, but this is what we really are excited about, especially over the second half of this year, which I'll touch on a bit. I had to use my logo here, this logo here. It's my favorite thing I think we've ever made on a graphic design perspective, so I really had to make sure we got it in. But today, the flow, this is a presentation or a format I've given a few places over the last few months, but the point here really is talk about, very briefly, Avalanche and its structure, how subnets fit into it, but then get more into subnet tutorial, how would you create your own subnet, talk about subnets versus L2, what are the trade-offs there, and like what people have been talking about, and then get into some new subnet designs and some of the roadmap that we're pursuing over the next few months, which, you know, if you're at a conference, especially our own, I get to share with you some fun stuff, right? So, I'm Patrick, I'm the head of engineering here. Someone made this, the NFT for me. It's my favorite picture of myself, I have to say. So I try to work it in as much as I can. But keep in mind, as I present to you today, I'm presenting the work of a team around me that far better than I am, that I shamelessly take credit for. So just keep that in mind as I talk about what we've been building and what we're doing. Some of them are back there laughing, so they know it. Yeah, let's get into it. So I always just start off, just in case people here are not super familiar with what we're doing and kind of how what we do is made up of. So first off, what is Avalanche? Well, the first thing it is, actually, let me go back there, is a consensus mechanism. The second thing it is a fast and scalable L1. And then the last thing it is a platform for deploying other blockchains or other networks. And that platform for deploying other blockchains and other networks is what really gets a lot of us excited here. So, you know, I think you've probably seen this slide or some version of it probably 100 times, which is how does Avalanche, the consensus mechanism, fit in? And, you know, we talk about all this other stuff we're trying to build on top of Avalanche. You may forget about like the core idea of what all started this. And this is this Avalanche consensus mechanism where through the use of repeated subsampling, you can achieve very interesting properties for consensus in general. So I think the thing there that's most important in us is typically the speed to finality is insane because of the way that the network works and the properties of this sub-repeated sampling. So you see some other stuff here around like Nakamoto consensus, and you know, if you're familiar with that with Bitcoin, and classical consensus, which is used by a lot of other proof-of-stake networks. I'm going to pass over that because I think there's some more interesting topics towards the end of the presentation, and just do a quick cover on some of the network subsampling component of Avalanche, which is the big goal, obviously, is you're trying to, in any round of consensus of Avalanche, so any block anywhere on the network or vertex in the DEG, your purpose is to pick a particular color at any one time. And the job of any honest node is just to, or really all the honest nodes, the goal is to align on one color. It doesn't really matter which. That's not really the point of it, but the point is that everyone agrees on the same one. If you don't have that and people subparts of the network agree on different things, you have safety failure. If you can't come to an agreement, liveness failure. So the whole point is just that everyone agrees on some color. All honest nodes agree on some color. And so I made this diagram to kind of show you what that means in a very brief way, and then I'll kind of expand into a little bit. So imagine you're this one node. You're sampling everyone around you. In this case, you pick k random ones on mainnet. That's 20. In this example, it's 6. And if you query one group of them, you can see in this case there's some oranges, there's some blues. If you get a supermajority, or whatever your parameter is tuned to, what we'll call alpha in this case of the k, you'll consider that successful. And then if you get a number of those in a row, you can then eventually accept that color, and then you're locked in. So very simple procedure in general, but the magical property of all of it is that it resolves very quickly, typically to one side. And so that's why it's called avalanche, is because you avalanche eventually to one side as soon as you get away from an equal split. So I'm not going to get too deep into that. I'm sure you've heard Goon talk about that 20 times better than me. But if you want to see a really cool simulation, recommend scanning that QR code. You can check it out. There's a beautiful illustration that Ted made that shows how the network in a very split state over a period of time rapidly changes to a fully centered network on one color. You can tune all sorts of different parameters, but I'm not going to focus on that too much here today. There's a lot of content online you can look at if you're curious. So what really I wanted to focus on and what we're going to talk about today is subnets and how they fit into this whole picture. So the very brief primer, obviously, is that Avalanche, the network, you may or may not know, is comprised of 3 different chains. And I think the one most people interact with is the C chain, and the second one they probably interact with is the P chain, which handles all the staking and everything that you would do on the network. And then there's also the X chain, which is a directed acyclic graph chain. They all have very unique and different purposes, but the one that that kind of coordinates staking and has to do with subnets is just the P chain. So in the primary network, you can move between anything in here. And the reason why I show this is when you're participating on a subnet, you have to keep in mind that you're also validating everything here. And before we ship some of the features we have coming, you may wonder, like, well, why do I have to validate this other network to validate, a subnet or do whatever I'm doing? It has to do with trying to have overlapping trust regions that are then beneficial for some cross-subnet communication and cross-subnet basically bridging and stuff, which you'll see as I get further along. But first off, subnets in general. I made this meme once and thought it was the coolest thing I'd made. So again, I love my favorites. So a lot of chatter about what a subnet is, what a subnet isn't, and I think that that's because of how low level it is in some sense. There's a lot of flexibility, so people are trying to craft a higher level narrative of, oh, a subnet is this thing, oh, it could never do that, oh, it could never do that. And a subnet, in as specific as possible, is just a very low level interface of what a group of nodes that are validators on Avalanche can do together. With the assumption that they run the same virtual machine and that they work together to achieve some form of consensus, whatever that means. And in some cases, I'll get to at the end, you may not even want to use it for consensus, but most people would in the case of a blockchain. So, well, why do we want this so much? Why are we interested in it? Why don't we just use the C chain to scale to the sun and the moon and whatever? Our theory, or the way that we think about scaling, is even if you pull out all the performance tricks, even if you hyper optimize everything, eventually what you're trying to do is maximize your available block space without undermining the eventual economics of the system that give it its safety. So in the sense of, like, let's just say you take it to the end and you optimize everything, wouldn't it be better to have 10 optimized everythings doing the same thing rather than one big optimized everything? If you have one huge optimized everything, you could apply the same technology to each one of the subnets that are operating in parallel and achieve factors more computation by sharing that everything. So when people are like, oh, you're giving up on trying to optimize the main network or trying to optimize a single virtual machine, no, we're trying to have more of those super optimized virtual machines for all the traffic we see in the world today. And that's what we call the Internet of blockchains, is that you have many of these things doing their own thing, interacting with each other. Now, in the short term, it's super great for projects. I think you heard earlier today about institutional subnets and what people are trying to do when you can control the set of participants. And then what you'll see towards the second half of the year is more of its use case for permissionless subnets. So, you want to create your own blockchain, and you don't want to be the one in charge. You want people to stake to it. You want people to participate in it, just like you would any other blockchain. But you don't want to build, the 80% of code that Avalanche Go maintains for you in the consensus engine, the storage, the networking. And so what I think we'll see at that point in time is all these great virtual machine developers that know what they want in their application layer stuff, but don't want to rebuild consensus, rebuild storage, rebuild networking, starting to build some really exciting stuff once we unlock a few features that everyone wants. And if you use Avalanche on a regular basis, you would have noticed the effects of people using subnets more so, particularly on the C chain. So the whole point, right, is in areas where there's a need for high composability, like in the C chain with DeFi, if you can have projects that maybe don't need that composability move to their own subnet, you can free up space for people that actually do want it or need it. That benefits everyone, right? So it benefits the people using the C chain. It benefits the subnet, whose users now pay a fraction of what they would have otherwise paid. And so this was a really awesome event that happened earlier this year where Kribata moved to a subnet and it rapidly decreased the fees that people were paying on the C chain. And then we also had DFK join. Over the next second half of the year, we expect to see a lot of this, except most of it will be from people that aren't yet on Avalanche launching for the first time their networks. So now you're saying, all right, I got kind of this subnet idea. I get kind of why you may be interested in doing it. Well, how would you even launch one? Or like if I wanted to start playing today, what would I do? Well, I took basically I couldn't show a video here. I've seen so many presentations where like, hold on, I just got this video 1 second, and then it never works or it goes back and forth. So I instead took a bunch of screenshots, and so pretend I'm doing this in front of a computer. So a few weeks ago, we launched something called the Avalanche CLI. So we have a lot of different dev tools that we use on a regular basis here, and we're trying to unify them into a single place, and that place is going to be the Avalanche CLI. So, excuse me. When you want to start playing around with the subnet, the first step is really just downloading this CLI tool, and I'll show you a QR code at the end if you want, but really just search Avalanche CLI. And once you download that, you'll get prompted to deploy subnet to do whatever you want. And so in this case, we're going to walk through and deploy the subnet EVM. So pretty simple process. You click deploy, and then you select the virtual machine you want to run on your subnet. Now, this underscores a very interesting point, and the thing that gets into the generality of subnets. It's not just a tool to deploy more EVMs, although that's what people seem to want to do these days. It's a tool to deploy any virtual machine. And as we see other interesting virtual machine frameworks get popular, we will extend it to run all sorts of stuff. So, I threw up a WASM here, I threw up a file here, but just as easily you could have a Move virtual machine, just as easily you could have, Bitcoin virtual machine running on this thing. And I think a lot of other projects will focus really hard on the one virtual machine they want to see and then get really behind it. We're much more agnostic to it in lower level. We want to see any interesting virtual machine running on Avalanche. So once you have that, then you, typical EVM fashion, you pick the chain ID. You specify a few of your fee parameters, what you want to see people use. You specify if you want any sort of airdrop and funds allocation, and then you can activate any number of precompiles. So this is a new feature we added to the Subnet EVM that lets you do a few interesting things right outside the box. And then at the very end, you'll get a little link you can throw in your MetaMask client, or in this case, Core, and start to play around with it. In this case, I went with PatrickNet. So it's a fun little tool to play around with, and we're going to keep pushing stuff through there. But the real question a lot of people have is, all right, you have subnets, but it seems like a lot of people are interested in what you could do instead with like a layer 2 or some other blockchain or something like that. And so I wanted to give a brief kind of overview of how we think about layer 2s, how they fit into what we're doing, and how they're a little different. So before I do that, I'm going to get a quick drink of water. We'll see how this goes. Thank you for the encouragement. Yeah. Gotta stay hydrated. It's hot outside. So. All right. So I'm actually going to sit for this because it's a little easier. I have some detailed notes. So when we're scaling blockchains, it's all about limiting how many people need to compute the same data and how much parallel data can be processed by all the nodes in the network. Now, people may go with different sort of bisection of what you'd want to do, but there can be almost infinite ramifications on the system design as you think about that. And so I wanted to start there, and then I'll kind of go into some of the things you should think about as an engineer if you're using a layer 2. So first of all, one thing that comes up a lot with layer 2s, and one of the big things is around security. So layer 2s take advantage of being on top of I'm going to stand up, it's easier. Basically providing their own security versus using another layer 1 security. So in the case of a lot of popular L2s like Arbitrum or Optimism, right, they're running on top of Ethereum. And so you can take advantage of maybe a single, in this case, in many cases, a single producer running on Arbitrum or Optimism, and then say, oh yeah, if something bad happens, I'm relying on the security of Ethereum instead. And so then they would say, oh, well, if you're going to launch your own subnet, it's its own network, the security comes only from the participants in the subnet. And yeah, you can totally run it that way. Some people don't want to trust another system, they just want to trust the network itself and the sovereign network that it is. Well, you can do that. So can a subnet provide its own security? Yes. Could you just as equally extend your virtual machine to checkpoint data on the C chain and then use fraud proofs just like you would with another L2? Totally. In that case, a subnet would just be a multi-sequencer network, and once the multi-sequencer got consensus agreement on what was, let's say, the unfinalized preferred block, you could then just post it to the network, just like you could any other L2 posting to Ethereum. Now, if you codified the state transition logic in a way where you could have fraud proofs, you could then trust the security of Ethereum, or you could use that for the C chain and then trust that the hashes or whatever's put there would eventually be fraud provable, and you could then provide some sort of security outside of the subnet itself. So I feel like it's sometimes easier to explain some concepts like this that are a little bit more nuanced through kind of a conversation of like what sort of engineering questions you may ask as you're looking at like L2s versus subnets or anything like that. So in this case, this is a conversation really about L2s and rollups versus subnets, but the optimistic L2 rollup variety. So in many ways, what's important in blockchain is to be fast, right? Like you want to not only have fast finality, but you also want to ship new features and develop very quickly. So when we're pushing out updates to Avalanche, we're changing thousands of lines of code on a bi-weekly basis. Now, if you're trying to ship all sorts of changes, but then you have this entire architecture built around fraud proofs and being able to relay it on another network, verify it on another network, you have this whole another layer of complexity. And then you also have to make sure that any changes you spin up or whip up, you can actually use in this fraud proof and you didn't break anything. If you're curious about some of the complexity around this, I highly recommend you check out Optimism's Canon implementation, which is like a compilation into a compilation into a compilation that you then run on Ethereum. It's extremely complicated. Now, if it works, fantastic, it's awesome. But knowing what we do on our side of development and knowing that we'd have to keep track of that and maintain that as everything got more complicated, practically speaking, it gets very difficult, and it certainly slows down your process. You're going to have to get all these audits, make sure it's provable. It's a lot of stuff. So with subnets, you don't need to do it to have fraud proofs on a network. You can, but because you don't have all these fraud proofs and everything, if you just want to maintain your own security and just execute, it can be very easy just to spin it up in a weekend. And I don't think I could write a fraud proof in a weekend. The second one is when you're running on an L2 or you're borrowing security from another network, your liveness is subject to that network's liveness. So if everyone else you're running is alive, but wherever you're trying to checkpoint state is not, well, you're kind of out of luck. When you have a sovereign network, you maintain your own fault isolation. So in a subnet, it runs on top of Avalanche, but only in the state that it manages who is a participant in that subnet. But all the traffic is contained solely to the actual participants in the subnet. So let's say that Avalanche, God forbid, were to have a problem, your subnet would continue on as long as it didn't crash the node or something like that, which typically in most of these consensus failures is because of some uptime thing or whatever. So you could have a much better story around fault isolation. The next one is finality. So when you have a L2, you're subject to some sort of, at least in the optimistic case, some sort of dispute period. So you may post a root, and then you have to wait, let's say, 7 days for someone to be able to post a challenge. Well, if you want to leave that subnet or consider it final, you're now bounded as a 7-day withdrawal period. Now, people may take that risk for you and say, I don't think it's going to fail, and then let you withdraw. But the dispute period on a lot of these is 7 days. If you have a sovereign network and you choose to do that, your finality is less than a second. So you give something up for the shared security. Certainly it's not perfect, but it can be quite a bit of time. And then lastly, an L2, or a lot of the popular ones, are really trying to be extensions of Ethereum. So general compute running with state checkpointed and security provided by Ethereum. If you want to use your own gas token, or you want to have your own configuration to the virtual machine, that's typically not something that they provide. So if you want to provide your own execution environment and your experience, it's not really possible if you just want to have your own network or your own rollup. So this one was just kind of my brief period of a little bit of coverage on what these things are. Subnets, though, they're not a silver bullet either, right? They're their own networks, they're their own blockchains, they're complicated. And there's a lot to think about when you're designing a subnet and launching a subnet. And we're going to get into this with some blog posts we'll draft in the next few weeks, just to kind of remind people they are their own networks. So in a subnet, at least before they're permissionless, there's a subnet control key. So whoever controls the subnet can add validators, cannot. It's really important that they maintain the security of that subnet control key. Otherwise, someone malicious could add a validator that isn't participating or something like that. The other important parts, how many validators? This has been a big question about subnets is, all right, well, the first few subnets only have 5 or 6 validators. And people are like, well, wow, subnets are not safe. Like, they only have a few. Yeah, I mean, we agree 5 or 6 validators is not the goal necessarily, and they can support many more, and we're really excited to see that. So it's important when you're interacting with the subnet that you think about kind of who's participating and who's validating. The other one is kind of the point of this. You're like, why does he have this funny comic? Well, I think it's funny comic up here. Well, subnets, because they don't take advantage or use the main network for anything besides just the membership tracking, the data itself is not stored anywhere else in the subnet. So if everyone in the subnet just disappears, well, and you wanted to resync that subnet, you really can't do it. So data replication and the peer count on that subnet is also really important. Lastly, I'm going to kind of, I think I'm already over here, so I'm going to move as fast as I can. But the other thing is people getting really excited about changes they can make to a virtual machine. Well, turns out that's really hard. And if you get a little excited or a little ambitious, you may introduce different bugs into your virtual machine. And if you're relying on something like Ethereum, where you have basic smart contracts, you may introduce failure patterns that you're not really interested in that could potentially really throw off your project. So I think that's another thing. And then lastly, minor one, subnets can be public or private. If you're using a private subnet, it's much harder to have proper data replication and get visibility into what's going on. So I'm already red. Can I go like a minute over? Great. So what's next? So we're done, right? We can go home. Subnets exist. There's 2 of them. We're good. That's all we wanted to do. We're done. No, not quite. So we have been working really hard on a lot of new stuff related to subnets in particular over the next few months. So you've seen Multiverse, a huge program we launched to encourage subnet development. We have also been building a lot of stuff behind the scenes that we'll launch to bring subnets to a whole nother level. So I'm going to share a few of those with you now and see how it goes. Yeah. So the first one people have talked about is around using subnets that use Avalanche as the currency. So a lot of subnets that exist now create their own currency or their own token and then use that as their own blockchain. So concept we're kind of workshopping and playing around with the use of some VM messaging primitives is the idea of a community subnet. So a community subnet may be built, generally speaking, for a general utility on the Avalanche network that may not be provided by the C chain, the X chain, or the P chain. So let's just say we wanted to have some sort of file storage virtual machine. And people wanted to use Avalanche to pay for that, or take Avalanche out of the seed chain or whatever like that to make it happen. Well, the concept we're playing around with is something called a Lazarus subnet, which is once you basically destroy some type of token on the primary network, lock it up, whatever it is, and then these subnets, because they all validate the primary network, can read deposits or read burns from the primary network and then recreate the corresponding amount of token on the subnet. So the reason where the name comes from is it's basically a born-again subnet. So you destroy it and then you're born again on any subnet you go to. Now you may be like, all right, well, am I locking myself in? Yeah, you're locking yourself in into using the subnet. But what you can do is if you have a shared contract for this, it's almost like a lock drop or something like that, where any number of community subnets could use the same pool of tokens of people trying to bring Avalanche value. And then you could, at the same time, when bridging or like permissionless subnet bridging comes in, bring it back and allow people to redeem it if they wanted to. So this ties into some of the VM messaging primitives that we're working on. And will be interesting to see how people use it. You know, you could build like a C-Chain Pro or like whatever that 10x is the gas limit you're trying to use or something like that, and put some supercomputers behind it or whatever. But this one's been interesting. I think the other thing we're looking at is something called a blockless subnet. So a blockless subnet takes advantage of basically the VM messaging and other aspects of the virtual machine interface that don't really need blocks. So the way I think about Avalanche subnets and really the virtual machine interface is more as like a peer-to-peer playground. So I took a small snippet of all the functions that are available to you over gRPC when you create your own virtual machine. So, you know, there's the standard stuff you'd hope, you know, get block, parse block, whatever like that. But the box in red is the ability to send arbitrary messages to other nodes of any kind. You don't have to have any blocks or any consensus going on. You could just as easily build like an IPFS, something like it, or you could build a messaging system, you know, or you could build some sort of data caching layer. And thus far, we really haven't seen anyone try to use it for that, but you could just as well. So something that we've talked about, or something that we've thought about, is you could have an opt-in messaging system as validators. So if you join the network as a validator, people would start sending messages to you, or you could have a relay system that just involves sending like ephemeral data back and forth. We were going to do this at the Barcelona summit, or tried to do it, and we ran out of time. But that's one that we've also kept our mind on. But you know, we got a few things here, and you may wonder what's coming next. So what we're really looking at, I think the way I describe our roadmap, or the way that we think about where we're going, is it should be, hopefully, kind of come out of what the community is asking for and what the community is looking for. And the thing that's super clear to us, and we're super excited about it too, obviously, is permissionless subnets. That's what everyone wants. That's what everyone's been asking for. Hey, I love this subnet thing, but I don't want to find my validators. I want to launch my own blockchain, but I feel like I can't because I got to be in control of who can join or whatever. So we've heard you loud and clear. We've been excited about this as long as you have. And so that's really our primary focus right now, and where we're spending a lot of engineering resources. So we hope to have really good news for you soon. We don't basically pre-share dates and launches, but you should keep your eye on that one. The next one, another thing you may want to know is cross-subnet bridging, right? You have to rely on a lot of third-party bridges if you want to use a subnet. It's a great intermediate solution, and a lot of great teams have stepped up to make it possible to bring things around. And hats off to them, they've done a great job. A lot of people have had a great experience with it. But for people that are starting from scratch, or they may not have a relationship with different people, like who could help them bridge, or come out of nowhere, it'd be great to just give it out of the box. And so that's obviously on our mind too. We think about really what's blocking use cases happening, and it goes permissionless, then it goes right into cross-subnet. And once you have that, you really can take advantage of what we think the power of the Avalanche ecosystem is, rather than just a particular virtual machine. But then once you get there, you're going to want, well, okay, maybe you don't like Golang as much as us. You want to use Rust. You want to use C++. You want to use Python to build your subnet. What comes up next? is making more tools to build Avalanche the platform. Avalanche the platform where you can have your virtual machine whatever you want. All your engineers know Java. Great, they can use some sort of Java virtual machine SDK. And we think that where people will go once they can see how powerful and easy it is to spin up their own subnet, will then want to start building much more custom subnets than they currently do now. Right now we see a lot of EVM stuff, but you could just as easily create application-specific thing, new general smart contracting chain. And I think that just takes a lot more flexibility than what we currently provide with our SDKs. And we'll make some cool ones too. So you can stay tuned for that as well. And so this is the last slide I have, which is if you're curious and launching your own subnet, want to make really cool subnet stuff, please apply to the Multiverse program. We have a ton of opportunities for people to get involved. If you're trying to figure out where to launch your next blockchain and you want to know more about what we're doing, we'd love to get involved with you. And there's a bunch of people here that are great at making that happen. But so thank you. Pleasure being here. I'll see you outside.